My name is Sriram. I'm the Director of Product Management here at Arista Networks, responsible for campus business. And I have here with me my colleague Ashwin. Ashwin, do you want to introduce yourself?
Hello, everyone. I'm Ashwin. I'm part of Wi-Fi team.
Yeah, thank you. So in this session, I know we've seen a lot of presentations on Wi-Fi 7 in slides. And what we thought we'll do is we'll bring those slides to life. So we'll share some real life experiments, results from real life experiments that we have done. We have some gear here. So we're going to show some Wi-Fi 7 technologies, including MLO and preamble puncturing working. So you get a first-hand experience. Yay, let's go. So before that, I'm going to quickly go through two slides. First is we launched our enterprise-grade Wi-Fi 7 access point, the C460. It's right here. Again, it's based on Qualcomm spec. It's got a 4x4, 3 Wi-Fi 7 access radios. It does have a multifunction radio, dual 10 gig, dual PoE, IoT ready with HADM BLE chip for high accuracy locationing, and it also has a Zigbee, Matter, Thread IoT radios, and finally it also has a GNSS radio for locking GPS coordinates for AFC. So, and then for those of you that have not seen our product portfolio, this is a quick snapshot. All the Wi-Fi 6 and Wi-Fi 6E products are shipping today. On Wi-Fi 7, we just launched our C460, which is our top-range enterprise-grade access point, and we're going to be pretty aggressive in terms of getting other products in the portfolio, especially in Wi-Fi 7 launch over the next couple of quarters. So you'll see some announcements come out. And if you need more details, please feel free to connect with me after the event, and I can share some more details of what's coming in the future. And the last point I want to mention is all our access points have the multifunction radio. It's a dedicated radio, tri-band. Does two purpose. One is it scans the environment 24/7. We've had this for eons. The scanning information is fed into our RRM algorithm, and it's also used for troubleshooting tools like packet capture, spectrum analysis, etc. And then the same multifunction radio can also act as a client. You can convert that as a client, run end-to-end client connectivity tests, and that can tell you where exactly in the network you have a problem, right? So we've had this capabilities for a long time.
Actually, quick question on the dual PoE. So that's not to provide, that because it requires that much power. I mean, it can provide redundancy also, right? So if one goes down or something like that.
Primarily for redundancy, yes.
Is there a hit? Like, does the AP reset when that happens, or is it just seamless?
It's a seamless failover. So you have two PoEs. If the PoE from ETH0 goes down, the AP doesn't have to reboot.
Cool.
Yeah.
So it pulls active.
Yes, it active power on both, right? And then the moment it sees that at the hardware layer, the power is missing from ETH0, it automatically switches.
So no client deauth or
no.
Oh, cool.
Yeah. All right. So without further ado, I'm going to invite Ashwin to talk through some results on our Wi-Fi 7 testing. Ashwin, yeah.
All right. Hello, everyone. I'm Ashwin. I'm part of Wi-Fi TME team. Today, I'm going to talk about MLO client behavior. We all know MLO is one of the key features of Wi-Fi 7. As most current clients incorporate dual or tri-band capabilities, MLO enables significant improvement with respect to high throughput, lower latency, and enhanced reliability in heavily loaded system. MLO in a heavily loaded system is a separate topic by itself, and we have another presenter who is going to, Vijaya, my colleague, is going to present that. In my session, I'm going to primarily talk about client behavior. So we all know there are various modes of MLO. There are single radio solution, multi-radio solution, but most popular client which is currently available today, they use EMLSR and STR MLMR. These are the only two options we have when we tested across the popular clients. So quick snapshot of STR MLMR. We have two links. It does a concurrent TX and RX over multiple links. It gives us an aggregation benefit. And when we talk about the other mode, EMLSR, Enhanced Multi-Link Single Radio Solution, this is something where the radio kind of listens. It has two spatial streams. It's gonna listen on each of the streams in 1x1 solution. As and when the packet comes in, AP sends MURT as a trigger frame, and then the client prepare itself to receive 2x2 in one link, right? And then it's gonna do a dynamic steering across multiple links. We all know about that, and we tested across multiple clients, which is currently available in the market. So we started gradually by like having that SSID in 2.4 and 5, and we saw most of the client connects in STR MLMR mode. And then when you have the SSID on 2.4 and 6, we see them connecting in STR MLMR mode. And when we have the same as when we have an SSID on 5 and 6, what we see is the client doesn't connect in STR MLMR, but rather it connects in EMLSR mode. So, and when you have all the when you have SSIDs on all three bands, right, we mostly see the client do STR MLMR either in 2.4 or 5 or 2.4 or 6, but primarily 2.4 and 6 are preferred way that the client currently joins the network. Moving on, we have tested across Google Pixel Pro, which is currently one of the popular clients there. When we have SSIDs there, we kind of see that it primarily does STR MLMR in 2.4 and 5 or 2.4 and 6, whereas it does EMLSR in 5 and 6. We did test it with Samsung S24. STR MLMR mode, it works fairly fine with respect to when we have SSID on all bands, but it does single link operation. Single link operation in the sense it basically does a MLO wrapper, but then the client does not advertise on the other link. Moving on with the OnePlus, the advertisements happens, it does STR MLMR in 2.4 and 5. And it does STR MLMR in, it advertises saying that it is capable of doing multiple links across, it can concurrently transmit and receive, but then the data flow happens only on the 6 GHz band. And then we did test it across Intel BE200. We see the link establishment happens across EMLSR. And then when you have SSID on 2.4 and 5 and 6, it does EMLSR. And when you have it on 5 and 6, it does EMLSR. Lastly, we have Qualcomm Fast Connect, which is an high band simultaneous network adapter, which has a capability to do STR MLMR in both bands, right? When you have SSID 2.456, it does MLMR, and it also does STR MLMR in case of 5 and 6 based SSID. So this is a high level takeaway. What we have seen. So now that we know that the popular clients are gonna hack this way, so this is all the initial experiments that we have, what we have come across, and we continue to do more experiments around this and try to characterize the behavior. So as an admin, we know that we have to design our network in a way that if we need aggregation benefit, we need to go on certain way, and if we need to have a latency benefit, we need to have certain aspects. Quickly moving on to the next topic of preamble puncturing. So we know without puncturing, what happens is usually when we have a wide spectrum, when the network, when one of the channels are busy, we kind of leave around the rest of the channels, right? So with the preamble puncturing there, we have when the interference is there in one of the secondary channel, we kind of puncture that particular channel, width, and we kind of use the remaining aspect. We'll see more of these in action, but this is in a high level that we get the end result is we get the more bandwidth and high throughput gains here. So this is a high level screenshot of what happens when the preamble puncturing happens. We have disabled sub-channel bitmap field true, and then we kind of indicate them like what kind of the channel width has been punctured, so that it kind of let clients know that it should not be transmitting on that channel, and proceeding further. So in a high level, the demo that we have planned to do is we wanted to show you guys the spectrum view of STR MLMR operation during the active data traffic. That is the first demo. And the second demo, we wanted to show the spectrum view of EMLSR during the active data traffic. And then we wanted to do preamble puncturing in live. So with that, I'll switch on to the other laptop and I'll try to set it up. So in the meantime, when it boots up, I'll just quickly explain the setup. We have an ICAO connected to my laptop, and I also have a Google Pixel phone connected via Visor. I'll be able to stream both phone as well as the ICAO here. First, we will see the spectrum view of 5 gigahertz, 6 gigahertz, and 2.4 gigahertz, and see how things are. And then we kind of run some speed test, and then we'll see how the distribution of aggregation happens across multiple bands, concurrently transmits across multiple bands. And then later we move on to the EMLSR mode, wherein how the packet switching across multiple links. That is what we wanted to show. And then as the last demo, we will quickly deep dive into preamble puncturing.
Okay. And you're using a sidekick too?
Yes, okay. This is a sidekick. Yeah. So we can see some energy here across 2.4 and 5, and this is what we currently have. And I have a client here. I'm going to connect to one of my SSID I already pre-configured to operate in, right now it is operating in EMLSR. So I have two SSIDs. My AP is operating in 2.4, 5, and 6. And the channels are static right now. So at 5, I've configured like 5 gigahertz, 80 megahertz, and 6 gigahertz, 160 is what I've currently configured. I have two SSIDs. So first, I will connect to the one that is STR MLMR, right? So the client gets the IP address, and then what we see is it is currently connected in 2.4 and 5. And then I'll quickly disconnect and then reconnect it. We will see it connecting shortly. Okay, so I have connected the client. So right now, as you see the properties here, it is currently operating in both bands 2.4 and 6. Now I will quickly run the speed test here. I already have had the URL, everything punched in. I'm going to run the speed test. Ignore the throughput result here, but what we see here is the spectrum, right? It goes at 6 as well as it will go at 2.4, right? If I stop the traffic, you would you'd start seeing the energy drop, right? In 2.4 as well as 6, right? If I start it, you'll see it concurrently operating at both, right? So this primarily tells that the popular Google Pixel is basically we are able to work interoperably with them to show that the data traffic happens concurrently across both links. So this is the first demo, and the second demo is going to be I will connect the SSID to EMLSR SSID, wherein the SSID is basically going to be in 5 and 6. Okay, so right now it is in 5 and 6. This SSID is in 5 and 6. What we see is the spectrum, the frequency change to 5 and 6 here. This is an EMLSR. It's operating in EMLSR, and we are going to run the speed test again. This time you see that the dynamic switching happening between 5 and 6, right? Okay, so this is where this is happening. The switching, the steering happening between those links. And I would also wanted to show the UI on the client section. So previously, so right now the client Pixel Pro, we have the ability to detect the MLO operations today, right now this test is EMLSR, so we will have the ability to say what mode it is currently operating. Not only that, we'll also be able to tell the link view. The link view will also have, it will tell which links are basically operating it, right? So this can dynamically change over the period of time, and then we have the ability to show them in the UI, and then we have the ability to say what kind of packets, what type of packets are going in which links and things like that. So
how configurable are the parameters as far as from the controller side or AP side? How much can you configure of MLO? Can you disable it entirely? Can you
yes,
allow different versions?
Yes. So by default, we have kept it disabled. So when we wanted to enable it, we can enable it, and we can do it enable disable during with the configuration. Yeah.
So this is Kevin from the bridge. How do you have something going on just for the demo to make it switch between 5 and 6?
Yes. So the main thing here is what is the so what we during our testing, right? We kind of found that when we have the SSIDs on all the 3 bands, these clients are not picking up STR MLMR using on 5 and 6. Right, it basically works with either 2.4 or 5 or 2.4 or 6, but not on 5 and 6. That's what we wanted to say. But what happens is when you have the SSID on 5 and 6, it's basically trying to operate in EMLSR, right? So,
but yeah, my question is your single radio test here where it's switching between the links. Is that something that the AP is controlling? Is in my testing, I normally see it, stick on one. 5 or 6 when you run the speed test. I don't see it switching back and forth.
Yes, no, it is a client properties, right? So the MLO of EMLSR is a client property. At the time of association itself, it will say that I wanted to use the dual link or whether I wanted to go for STR MLMR or EMLSR. So in this case, when you have an SSID on 5 and 6, the client decides to do EMLSR as against to STR. We all expect it to do an STR MLMR and get the aggregation benefit, right? But it is the client's properties, and it changes the way that it is.
Is it the same client that you're using, Kevin? Do you know?
I mean, I test with all the same clients on his list, but generally when I'm doing like a 5 and 6, it picks single radio, but it only uses one link. I don't see it switching back between 5 and 6.
Okay.
Yeah, that's interesting, Kevin, because here you can actually see it, use both the bands, right? You can see 5 and 6. So again, I think I also want to say that every version of the software that runs, right, you're going to see some updates to the driver, right? So Kevin, I mean, happy to kind of chat offline and take a look at your setup and see what's going on. But yeah,
but your APs are not doing anything.
Differently.
Yeah, because it's standard, right? We let the client pick what they want to pick.
Yeah.
Okay.
And
are you
just use
Update your iPhone, Kevin. That's what they're saying.
so basically with the client testing, you're not seeing any kind of threshold because you're just testing one client and it's deciding to do MLO.
Yeah, it is.
But you're not seeing like some sort of threshold with other clients where if it's the only one on that AP, it's going to decide not to do MLO. Or what happens when you've got more than 10, 20 clients on that AP? Is that when some devices then trigger to go, okay, I'm going to use MLO at this point?
So we haven't gone that far yet.
So Rahul, we have in a later session, Vijay will talk about, we have done some simulations with multiple clients, right? Probably we'll address some of those then.
Okay, because I'm curious if the multiple clients are also
it's a mix of it's a mix of legacy clients and MLO clients. We'll share some results. We have some data there as well. Yeah. But this is really to show, hey, Wi-Fi 7 is here. It's running, and we can show all the statistics in our in our UI as well.
So with this test, are you suggesting that when people purchase your Wi-Fi 7 APs, they turn on MLO?
So I think our first guidance is obviously got to be on 6 gig, right? All customer, I mean, like that's what we tell all our enterprise customers. On Wi-Fi 7, like I said, we've been talking to a lot of customers. We're doing some, early field trials. And I mean, if you look at Wi-Fi, the refresh cycle, right? It's typically once you deploy a gear, it's not going to come out of the ceiling for the next 5-6 years, right? So you want to future-proof your investment. Of course, there is going to be a premium that customers would have to pay for Wi-Fi 7, but a lot of the enterprise customers that we are talking to, especially the global Fortune 5000s, they are ready to deploy Wi-Fi 7. And our guidance is when you deploy, start with the building, right? Validate your environment, ensure that that network is stable, understand your the client mix in your environment. I mean, obviously, we are not going to have too many clients right now, so it's more like a crawl, walk, run approach, right? In terms of enabling some of this config, but we provide the option to enable, disable a lot of these functionalities on the access point. But we are seeing, like we are having discussion with a lot of customers that are looking to refresh in the next 6-9 months, and they are definitely looking at Wi-Fi 7.
Well, the test looks pretty clean. So are you also having conversations with the device manufacturers? Have you seen anything weird, like maybe something that doesn't match up with what the standard shows?
Yeah, I mean, see, if when you look at the table, you look at how every client is behaving, in its own, right? They have all their own mind. Even in 6 gig, we looked at how Android and Apple differed in terms of how they discover the 6 gig SSID, right? So that's going to continue. Of course, we work with most of the manufacturers here, because we send our APs to their labs to test them early. We get some of their chipsets. That's an ongoing conversation we'll continue to have. Hopefully, I think we are seeing, at least with the current set of devices, we're seeing that most of them have very similar behavior, and you'll see some vendors kind of update their driver to be standardized with other vendors as well.
And how's your testing with like the data rates that you're seeing? Like, are they, because it's not the advertised 46 gigabits.
Okay.
You said ignore
that's where we started. But
a big number earlier, so
That's all we
no, I think the real benefit to us is the fact that you're able to use 2 bands,
yeah,
right? In those conditions, that's really cool, right?
Yeah.
Especially EMLSR. I mean, you're seeing live in terms of how dynamically they're picking 5 and 6 gig, right?
No, I think it shows it's a good realistic test.
Yeah.
And I think with your interface, would you be able to show like what data rate it has?
Oh yeah, yes. Absolutely, yeah. So if you want to just quickly log in, so we will show all of that.
Okay.
I mean, you saw the capability of the client, right? EMLSR.
Yeah.
But we'll show everything. We show a client view and we also show a per link view.
Yeah, because the client's here on this table and the AP is
No, the client.
The AP is all here.
Yeah.
This is our
right under the AP.
Wi-Fi 7 access point,
Yeah.
and you can come take a look up.
It's working better than the hotel Wi-Fi. So there's that.
And then that's
upgrade
right here. Yeah, Keith, sorry.
I think you could add one thing to this demo to even make it a little more impressive.
Yeah.
Sure.
Add a column over there that shows the Ethernet uplink to your switch
Okay.
Yeah.
Thanks.
to finally
Yeah.
prove,
Yeah.
yes, you do need multi-gig.
Yes, we'll do.
Yeah, sure. We'll
Yeah,
update that.
and that will drive a lot of network switch refresh, which is good for us, right? Sorry, I know.
So
we had to go through preamble puncturing.
Yeah, we'll go through the
preamble puncturing. Yeah, that's a cool demo.
So we don't want to induce an actual interference and make a lot of chaos. So we
Sure we
can
do.
the interference through the software. Maybe we'll do it at the 6 gigahertz, and we'll see the interference on live.
320. I did it.
So we're not sure. We need to debug and see what has actually happened. But here it's the same demo that I'm connecting on MFD, and you would see it is operating in 2.4 and 6 in the MLMR mode, and we are running the speed test. As you see, the 2.4 and 5, 6, there is not much of energy being picked up, and when we started the test, you kind of see 6 gigahertz getting populated, and energy on 5 is not there, and 2.4. So now we will be puncturing one of the 40 megahertz channel out of 160 megahertz of spectrum, and then once you start puncturing, you would see that energy drop in there, and then the throughput also has gone down. So instead of operating at 160 megahertz, it is currently operating in 120 megahertz. So we'll move to the 2.4 to show actually how the concurrent transmission happens, and then we'll shortly unpuncture, we'll unblock the puncturing, and you will start seeing that it uses the full spectrum. Right. So right now we have unblocked the puncturing through the software, and you would start seeing it, and then the throughput slightly climbs up. Right.
That's outstanding.
Yeah.
Ooh.
That's
Yeah, absolutely.
Yeah.
Something that you expect to see, but you've never seen. I hoped it would look exactly like that, and it did. So
That's
Yeah,
okay. We'll try it again. Okay. One last try.
What was the interferer you're using?
Yeah,
they're
We are
pulling channel
actually
out of
just
the software.
introducing
Oh.
interference directly on the software on the radio, just to show, because we're
don't
just
know.
netting outside interference. But it's just assuming that there is external interference coming from the radio through software, just to show that
Fantastic demo.
Yeah.
Kevin, Keith, I hope it lived up to the expectation of what you expected from the.
Yeah, we are going to retry it again.
Couple of weeks back.
So right now it is going at 2.4 and 6. Let me click on 2.4. We see energy here as well as 6, and then.
Oh yeah, no, you puncture. Yeah, no, it's that's gone, isn't it?
Yeah, it's going on, and yeah. So why don't we do it back, and yeah, and then on the live you would be able to see it, right? So this was the area of punctured, and you will see that actually in live.